Welcome to Clean Med KE, your home for clear, structured, and clinical education. Today, we conduct a forensic analysis of cardiac mechanics, mastering the pressure-volume logic that governs every beat. The heart is a dual pump system. The right side handles the pulmonary loop to the lungs, and the left side handles the systemic loop to the rest of the body. The core rule here is the flow law. Blood only moves down a pressure gradient, from high to low. Valves act as passive mechanical guards. If the pressure gradient flips, they slam shut to prevent any backflow. Before a muscle contracts, it needs an electrical signal. The SA node starts the spark, but the real genius of the heart is the AV node delay. It holds the signal for about 0.1 seconds. This delay is critical because it gives the atria time to squeeze that final bit of blood into the ventricles before the main ventricular contraction begins. It's a perfectly timed sequence that prevents the chambers from fighting each other. We can simplify the entire cardiac cycle into 4 distinct states. Filling, the heart is relaxed and taking in blood, with the AV valves open and the semilunar valves closed. Isovolumetric contraction. The ventricles start to squeeze, but all valves are closed. Pressure is skyrocketing, but the volume doesn't change yet. Ejection. Pressure finally blows the doors open, and blood rushes out via semilunar valves, with the atrioventricular valves remaining closed. Isovolumetric relaxation. The ventricles relax, the doors snap shut, and pressure drops back down, so we can start over at state 1. Valvular gating, the logic of heart sounds. A common mistake is thinking valves have motors. They don't. They are passive doors that react to pressure. When ventricular pressure becomes higher than atrial pressure, the mitral valve slams shut. That's your S1 sound, the Lub. When the pressure in the aorta becomes higher than the pressure in the ventricle, the aortic valve slams shut. That's your S2 sound, the Dub. If you hear a heart sound, you are hearing a door closing because of a pressure crossover. The Wiggers Diagram is the master flight telemetry for the heart. It layers the ECG, pressure curves, and heart sounds onto a single timeline. Notice the pressure crossovers. The exact millisecond the ventricular pressure curve climbs above the atrial curve is where S1 is triggered. It proves that heart sounds are clinical markers of precise mechanical transitions. Now let's look at the pressure-volume loop. This graph is a map of one single heartbeat. The bottom horizontal line is the filling phase. The right vertical line is that isovolumetric squeeze, where pressure goes up but volume stays the same. The top curve is the ejection of blood, and the left vertical line is the relaxation phase. It's a constant loop that tracks exactly how hard the heart is working. Tracing from the bottom right, point A to B is filling, where volume increases at low pressure. At point B, the mitral valve closes, and we enter a vertical climb. This is isovolumetric contraction. The ventricle is a sealed box generating massive pressure, but the volume is locked at 120 milliliters. At the top left, point C, the aortic valve opens and blood is ejected, causing the volume to drop. At point D, the valve snaps shut. We then drop vertically back to the start. This is isovolumetric relaxation, where pressure falls while the volume stays at a residual 50 milliliters. This loop provides a forensic snapshot of health. The physical width of the loop, the distance between your maximum and minimum volume, is your stroke volume. The height tells us the systolic blood pressure. If the loop narrows or shifts, we can forensically identify heart failure or valve disease. Think of the ventricle as moving between 2 worlds, the low-pressure atrial world and the high-pressure aortic world. The vertical isovolumetric lines on our loop are like mechanical airlocks, allowing the heart to jump between these pressure extremes without blood ever flowing backward. Let's apply this logic. If a patient presents with a split S2 heart sound, we have to look at the mechanics. Based on the PV loop we just mapped, Which specific corner, A, B, C, or D, represents the closure of the aortic valve and the S2 sound? The answer is point D, the top left corner. This is the exact millisecond ventricular pressure drops below aortic pressure. Ejection stops, the door slams shut to prevent systemic backflow, and the relaxation airlock phase begins. To summarize, blood only moves when pressure allows. Heart sounds mark valve closures at crossover points, and the PV loop is our map of mechanical efficiency. If this breakdown helped you, please like, share, and subscribe to Clean Med KE.